Very good morning, students. I hope you all are enjoying your holidays. So now it's time to have a quick revision of what we have done in our classes before we have our summer holidays. So as you know, the first chapter in our book is measurement and experimentation. So let's have a quick revision of this chapter. So the chapter we are doing here is measurement and experimentation. If you remember, in the classroom you must have done some measurement from the vernier calipers and screw gauge, which is something new for you because we haven't done any measurement before before classes from these instruments. We have studied some very important units like light year that we haven't done in any classes before. So we will have a revision of these things. Now as the name of the chapter is measurement and experiment. So before we talk about what is measurement, let's talk about why we need measurement. What is the need of measurement? Why it is so crucial, why it's so important to have measured something. Subject like physics. In physics we do lots of experiment to find result of a certain quantity. For example, if you want to find out the acceleration due to gravity, then we have to take a pendulum, and to take a pendulum we must have a certain length of the pendulum. We have to measure the radius of the metallic ball, then only we can find out the acceleration due to gravity. That means in this experiment we have to measure the length of the wire or the string, we have to measure the length, the radius of the ball. So without measurement we can't perform such experiment. When you go to the class 12, there is an experiment in which we have to find out the focal length of the given convex lens. Again, in that case we have to measure the distance of the image and object. So in such cases, without taking the measurement, we can't perform experiment, and that's why the measurement of the physical quantity is very, very important. Right? Now let's talk about what is the definition of measurement. So as you can see on the board, there is a definition of measurement which says measurement is the process of comparison of the given physical quantity with the known standard quantity of the same nature. Now this is a bookish definition. Let's quickly understand what this definition is actually saying. Suppose I have this pipe. Now I don't know what is the length of this pipe. Now we need to find out the length of this pipe. So in the definition we have written that it is a process of comparison of the given physical quantity. Given physical quantity. Now in this case, in the present case, I have to find out the length of this pipe. So the given physical quantity is nothing but length of the pipe. So suppose I am drawing a pipe here. So this is the given physical quantity. Is length. Now I want to calculate the length of this pipe. Now what is the next part of this definition says? With the known standard quantity. Known standard quantity. That means now we must have something called standard quantity, which is decided by the Bureau of Measurements. They decided that what will be the standard of the length, and they say, let's say standard of the length is say 1 meter. And how do we decide the 1 meter? We have the definition of 1 meter later on this chapter. So they decide the standard of the length is, let's say, meter. Now to compare the meter, we must have some standard quantity as well, right? Now how will you measure this length? Then for measure the length, we have this scale. As you can see, the scale is of 15 centimeter, right? So by using this, I can find out the length of this pipe, right? So as you can see, this is 1 time, then you put 2 times, 3, 4 times, whatever the length, we can measure the length of the pipe. So what we are doing basically, we are comparing the length of the pipe with the help of with respect to the length of the scale, right? So that's your measurement. What we do, you can see, measurement is the process of comparison. As you see, I am comparing the length of the pipe with the scale of the given physical quantity. What is the physical quantity here, which is unknown? That is the length of the pipe. So the given physical quantity here is length. With the known standard quantity, now we know that this is known, this is standard. Standard means if this is a scale of 50 centimeter here in India, if you go to in any other country, then again the length of 15 centimeter scale would be the same. So why? That's why this is a standard quantity. Last thing, of same nature. Now what does it mean? Of same nature. So this means, can you determine the length of the pipe with the help of a weight of kilogram? No, we can't find it. Can we find, we can say, with the help of a watch? No, because it shows us time. So if you want to determine the length, then we must choose a standard quantity that is of the same nature, right? Let's give you one more example. Suppose I have a bottle, and in this bottle I have certain amount of water, right? Now how do we, I say that I want to find out the volume of this water. So can I measure the volume of the water with the help of just scale? No, we can't, because the nature is not same. Although this is a standard physical quantity, but they both are not of same nature, right? So to measure the quantity, first we need some standard quantity, and second we need, it must be of the same nature, right? So I hope you have understood what is the definition of the measurement. Next important part of the measurement is the unit, because measurement is taken in a certain unit. Suppose I am measuring the time. I say that I have to take this lecture of 20 minutes. So here minute is a unit of time. If I say I cover a distance of 5 kilometers to reach school from my home. So here basically 5 and kilometer. Here kilometer is the unit of the length. So to measure something, we need a quantity known as unit. What is the definition? It says, it is a quantity of a constant magnitude which is used to measure the magnitudes of the other quantities of the same nature. Now again, let's break this definition and understand this definition part by part. It says, it is the quantity of a constant magnitude. Now, let's suppose, again, I am taking the example of the scale. Let us consider the length of the scale is 1 meter. I know this is not the scale of 1 meter, because 1 meter is something like this. So, this is not the scale of 1 meter, but we are taking it as this is a scale of 1 meter, right? So suppose this is a scale of 1 meter, right? Quantity of a constant magnitude. Now we fix the magnitude of the length of this scale as 1 meter. Now it is not changing with time, with distance or any other quantities. It is constant, which is used to measure the magnitudes of the other quantities of the same nature. Now I want to use the scale to find out the length of my pipe. Here it is. Now suppose I want to measure the length. So as you can see, this is the scale and this is the pipe, right? As I said, this scale is of 1 meter. So that's 1 meter. Now it is going up. That's 2 meter. It is going again up. So it is about 3 meter. Can you see that the length of this pipe is 3 times the length of the given standard scale? Because I have considered the length of this scale was 1 meter. And you know that this pipe was this. And the length of the pipe was 3 times the length of the standard scale, and which is of 1 meter. So I can say the length of the pipe is 3 meter. Now a very important thing come here. The measurement I have taken the measurement of length, right? There's a length. Comes in 2 parts. First we have a number here, that is 3. And second we have unit. So in measurement we have 2 things. First is the magnitude and multiply by its unit. You know unit is fixed. I have fixed to 1 meter. Now the length of the pipe is 3 times of the fixed length, that is 3 meter. So here the magnitude of the unit says that how much time the quantity is of the given standard result. Here the length of this pipe is 3 times the length of the standard scale, that is 3 meter. Suppose I have a pipe of the let's say length of 5 meter. That means the measurement will say 5 meter. That means how much time it is? 5 times of the given standard quantity. So this is how the measurement takes place. Again, I'm saying it's have two things. First, the magnitude, which says how much time it is of the standard quantity, and second, we have the unit, which is fixed by, I said, the international organization, which fixed that this is the 1 meter. Okay, this will be 1 meter for every country, and we can say for every planet. All right. So this is your measurement. Now let's talk about the types of units. So we have 2 types. First, I must say that it is fundamental, units, and second, derived units. Now what are they? Let's quickly talk about them. First, fundamental. Fundamental is something which do not depend on any other quantity or any other unit. They are independent. For example, if I say the length of any quantity is, suppose it is 1 meter, Now, is there any other unit you need to define this meter? No. This meter is standard and it is independent. It does not depend on any other unit. For example, you say time, and time is, let's say, 1 second. Now let's talk about second here. Do you need any other unit to define the second? No. It is independent. So there are some units which do not depend upon any other unit. And these units are called fundamental unit. We have 7 fundamental units. I will talk about it later. First, we'll talk about the derived unit. Now, derived unit, as the name implies, derived. That means we are deriving these units with the help of some other unit. For example, you want to find out the unit of speed. So, like we have the unit of length, this is 1 meter, independent. The value for what to find out the unit when you want to measure the speed, what we'll do, I will write distance upon time, and you know that the unit of distance was meter and this was second. So this unit of speed is nothing but meter per second. That means to find out the unit of speed, we need 2 things. It is not independent. It depends upon meter and second, right? And that is why this is not fundamental, but this is derived, because we are deriving it from the fundamental units. Let's say one more measurement. Suppose I want to find out, let's say, density. Now you know that density is nothing but mass upon volume. So mass upon volume, the unit of mass is kilogram and that of volume is meter cube. So to find out the density, we need first kilogram, which is a fundamental unit, and we need 3 meters. And that's why this is not our fundamental unit, so that is our derived unit. So in short, the fundamental units are the independent unit. They do not depend on any other units, and the derived units, basically they are not independent, they depend on the our fundamental units. Now let's talk about the system of the units. There are certain system of unit we follow in our physics or in every sciences. So let's talk about that. We use the first, which is most, I can say, used system, is called, so we are doing the system of unit. First we have MKS system. Now what does this means, MK system? This MKS stands for, M stands for meter, K stands for kilogram, and S stands for second. So it says that suppose you are doing certain experiment, and in that experiment you need to measure length, time and the mass of the body. Then you must take this system and must measure the mass in kilogram, the length in meter and time in second. You can't change any of the quantity. You can't change unit of any of the quantity. Let's say I say that I am doing the experiment in which I need to measure the mass, length and time, I take mass in kilogram, time in second, but I say that I'll take the length in, let's say, kilometer, right? You know that if I do that, I'm not using this system. I take mass in kilogram, alright. I took time in second, that's fine, but I took length in kilometer, which is wrong, because if you are performing certain experiment, we have to use same quantity which is given by the MK system. If we are measuring the mass in kilogram, if we are measuring the time in second, we have to measure the length in meter. Otherwise, your answer will be wrong. So that's your MK system. Second, we have CGS system. Now, what is CGS system? In this, C means centimeter, G means gram, and S means second. Now suppose I am performing an experiment again in which we have to find out, we have to measure the length, mass and time. Now in this case, I will measure the length in centimeter, mass in gram and time in second. If someone says, okay fine, I'll measure the length in centimeter, mass in gram, but time in hour, no, that will be wrong. We can't change the unit, right? And the last is FPS. Now what is FPS? Here F stands for foot, P stands for pound, and S stands for second. So if you are using the FPS system, we have to measure the length in feet, your mass in pound, and time is in second. So one thing you must have noticed here, in all the system, the time is always measured in seconds. Suppose you are, let's give an example, in any question, it is given, let's say the length of the quantity is, let's say 5 meter, and the mass of the quantity is 1 gram, and we have again time given, that is 10 seconds. Now when we solve this question, we must use any of the given system. Either we can use MKS, CGS or FPS. But we can't use 2 or more systems in a single question. If you do that, your question will be wrong. So either we use MKS, CGS or FPS. Now in this case, length is in meter, that's fine. Time is in second, that's fine. But the mass is in gram. That means it is using the mass of the CGS system and length and time of the MKS system. So we have to change this mass into the MKS system. So unless we convert this mass into the gram, that is minus 3 kg, our question will be wrong. So we have to change it first, then I will use this these values in the question. So I hope you understood all these things, although you have done in this classroom as well, but I hope you have revised all of these things. In the next lecture, I will talk about some fundamental units and quantities, their prefixes, how do we convert meter into centimeter and all, and some important units of length. Till then, thank you so much.